Okay, so now we're at the point where I am not even sure if anyone can see this. I hope you can see this. This is going to be a talk about testing. Do you even test, fam, bro, bruv, pal? This talk basically started because getting into testing, how to test is a frequent topic that comes up in virtual coffee. This is by no means in depth. This is sort of a teaser, and I'm hoping to maybe do more content for this in the future, but just to give people a gist, and we will see how that goes. So let's kind of get into it. Yeah, so quick and dirty guide to what tests are and when and why you should write them. First, let's just start with some grounding literature. What are tests? Or like the tests that we're talking about right now, what are tests? We're specifically talking about automated tests. Automation testing, test automation is software testing technique that performs using special automated testing. There's the word automated testing over and over to execute a test suite case. This is a very fancy way of saying that like we are specifically referring to code that tests other code, as opposed to manual testing where you as a person or a group of people are making changes and observing effects, right? This is something that like you can tell to go run tests. You are not running the test yourself. What types of tests are there? This is a question I get asked a lot. This is something that's very, in my opinion, confusing. There are many definitions of tests. Many people have their own definitions that differ from other people's. There's a lot of crosstalk. Largely, I think that the specific names are irrelevant. I think what is more relevant is just to recognize like the shapes of tests you might do. So we're just going to briefly talk about those. The first is unit tests. Unit tests are just like tests to test a specific function, class, module, or library. Basically, if you are testing a specific thing in your code base, that is a unit test. This is probably the most common type of test, the most well-known type of test, the easiest type of test to set up because you're not sort of like interacting with the UI. Typically, you're not interacting with like a DB layer. It's just like, hey, I have this function here. I'm going to pass some inputs in, get some inputs back out, see if they're right. That's your unit test. Second, integration tests. There are lots of definitions for integration tests, but I prefer to just say, if the test crosses at least one layer of your application, it's an integration test. It's testing like the boundary between two things. You know, if you're hitting the DB, that's probably an integration test. If you're hitting the UI, that's probably an integration test, right? It's got to cross a layer to get meaningful results. Integration tests are very important. They're very useful. They're very good at like things that go wrong or could go wrong. What do we do when they happen? So they can be used and they're okay. Finally, the one I also hear a lot, end-to-end testing, E2E testing. Again, there's lots of definitions. I like to think of these as tests that mimic user interactions. They usually start at an entry point to an application, someone visiting a page, someone clicking a button on a screen. They go through the entire process and they usually test what that, like at that point of entry, what happens next from the perspective of the user. A page opens up, a dialogue opens up, they see a profile picture, right? Behind the scenes, you have an entire application working to make all that happen, but the end-to-end test is sort of like very, very high level. And these are basically the three types of tests you're ever going to be doing at any particular time. Why are tests? It's great that we have these things and they're cool to like talk about and tweet about, but what is even the point? Why should I do this? Why is this not just like wasting my time? I'm just writing the code slower. I can test myself. I can do this manually. I can look at the code and see that it works, et cetera, et cetera. There's sort of two phrases I always think about when it comes to testing and like software in general. In the face of ambiguity, refuse the temptation to guess. That's from the Zen of Python. If you've never heard of the Zen of Python, you should look it up. It's short, it's sweet. It's like a really fun little piece of prose. But yeah, so often I see people write code and it's like, hey, does this work the way you think it does? It's like, I think so. It's like, well, you don't have to think so. You could just write a test and be sure. Otherwise, you're gonna find out anyway at runtime, and either you or your users will discover this, right? So just why not write the test? And there's this other quote that I really like, that which can be destroyed by truth should be, if you have an assumption, a test will tell you whether you're right or wrong. But like after that point, like that's where knowledge starts, right? Like now that I know that I am right, I can move on with confidence. Or now that I know that I am wrong, I can become right. But you don't get to either of those things until you are sure. And tests make us sure. So generally, there are 3 reasons, in my opinion, why you would want to write a test in the first place. And I think like this is kind of getting to the core of like what people wonder about, like, what am I doing this for, or when should I do this? First, to prove an implementation. This, I think, is the standard way, the first way people get into tests. You've written some code. I don't know if this works. The code is large enough and complex enough that it's hard to tell at a glance if it does what it's supposed to do. You're doing some complicated logic. You're handling a lot of different cases. You've got complex ifs. You've got control flows. Write a test. Just write a test. You know what it's supposed to do. See if it does it. Second thing, to prevent a regression. The second way to write tests, and my favorite way to introduce tests to a code base, is when something inevitably goes wrong. Oh no, something has gone wrong in my code base. Whatever shall I do? I shall fix it. But how do I make sure that it doesn't happen again? That, my friends, is where you write a test. So I have a general rule with my code bases. If a bug happens, if the fix of the bug involves changing code, I write a test to make sure that that bug cannot happen again. Tests are great for that. And over time, you start to build up more and more tests, and more your code becomes more resilient against future errors. No more regressions. It's great. Third thing, this kind of gets into TDD, test-driven development, which is not the point of this talk, but to enforce a specification. I spelled specification wrong. My life is over. This is all for nothing. But yeah, very frequently as professional software developers, we don't just code on the fly. We are given a list of criteria. This site should do this. This application should do this. The rules of the system are X, Y, and Z. How do you make sure that the code that you write actually conforms to that specification? Well, you can try really, really hard to do it right, but you can also write tests. And honestly, we have a lot of conversations about documentation. One of the best pieces of documentation a code base can have, living documentation that makes sure that you stick to it, is to write specifications, and it is to write them as tests. Tests are living specs for your code. They prove that your code does what it is supposed to do. It's very good for that. Okay, I've got a couple of brief examples, just little snippets of code. We're going to get into it a little bit, but not too much, just based on some stuff I've been doing recently. Just testing implementation. A couple of weeks ago, I wrote some code for a little take-home assignment. This is just a snippet of what is about maybe 150, 200 lines of code that all sort of end up funneling into this little function here. And I was like, this looks right, but I have no way of proving that without running it. And it's like, well, at that point, I should probably write some tests. So I wrote some tests. And these look relatively simple and relatively trivial, and they kind of are, but that's sort of like the important thing, right? I'm not testing every line of code I've written, but hey, all of this like points to this little function API. Let's just write some tests to make sure that this does what I want it to do. And now I feel super confident about my code. I feel more comfortable sharing it with other people. I feel more comfortable that it's right, and it really took almost no time to get these tests set up. So that was a win for testing. If you want to test specifications, this was some code I did for another project. Here we're being very explicit, right? It's like, hey, we have an API. What are the rules of the API? Those have literally become my test cases, and like we can keep things like very generic in that way. And it's like, hey, this was for like a Roman numeral converter. And it's like, hey, it should accept these values. It should make these changes. It should block these changes, right? And again, I'm not caring about like the internals of the code I'm writing, so to speak, but I am caring that like the APIs that I've defined are working in a way that I've said that are clear. And again, it doesn't take that much to add these tests. The tests you can see, so they're not like especially long or especially complex. But once you have them, you just feel so much more confident about your code. You feel more confident about changing your code and doing refactors. I can change all the internals of the code that I want. I can swap out classes for functions. I can do everything in one page. I can split things into modules. As long as my tests still pass, then I know that I'm still meeting my specs, and it's a very good space to be. I just want to end with some real life scenarios and what I would test, because this is, I think, another question you see a lot. People just like, well, I've got an app. What should I be testing? A personal website, I feel like, is a good standard example. The first thing I'd say, test the success and failure case of any third-party API. We saw earlier, some folks are integrating with Dev2 and GitHub. Well, what does your app look like if it can't fetch something from Dev2? What does it look like if it can't fetch things from GitHub? Does it just crash? Does it show the user some sort of like blank screen, an error message? What bubbles up? You should kind of know about that. Anytime your app needs to do anything that is outside your code base, you should write tests to make sure that like that works the way you want when it's successful, and it works the way you want when it is unsuccessful. And I would argue the unsuccessful part is more important than the successful part, because like it will happen at some point. That API will fail because it's just how external connections work. Throw a test in there. It's really good. Accessibility testing. There are tools. I have some at the end of this slide deck that sort of talk about the way to like bake in accessibility testing into your automated tests. So every time you build your code, whenever you commit, whenever you push to production, whenever you push up to GitHub, it will just tell you if you're following accessibility guidelines. It's not perfect, but it is a start. It makes things a lot easier, and it keeps you from having to like run all the accessibility tests yourself, and that's super important. Let's say you're doing some sort of small application. Any non-trivial business logic should have tests. Like that example earlier, any sort of code or module or file that is hard to determine at a glance if it is working right, make a test for it. You know what it should do with certain inputs and what it shouldn't do with certain outputs. You should test that. You should test what happens if it gets weird outputs, right? And depending on the way you set up your code, you can make it so that it can't accept those weird outputs, but you should know. And that's what tests are for. Like I said, prefer testing interfaces over individual functions. If you have a module of code and it's got like 12 functions in it, but you're only exposing 3, test those 3. Test the boundaries of those 3. Test if those 3 work. You know, and if like those work, you're reasonably assured that like everything inside works as well. If you start down the path of I'm going to write a test for every single function that I write, you will have a lot of tests, maybe a lot of time wasted, maybe tests that aren't really giving you much information. But testing an API gives you a ton of information. It tells you that the guarantees that I want this to do, it does them. Test that your database round trips work correctly. If your application uses a DB, I would heavily suggest just having some tests to make sure that you set up all that logic correctly. That's typically a place where people go wrong, and it's worth checking out. Finally, I just want to throw a couple tools. These are a little JavaScript centric. I think most of the folks here, but like there's versions of these in Python, in C#, in Java, in whatever language you like, in Ruby. So check them out. Jest for Jest unit tests. Jest is great. It's all over the place. It's super easy to set up. It's like baked into things like Code Sandbox. It's there ready to go. I love Jest. Cypress for UI tests or basically everything. Cypress is like a one-stop shop for tests. It's definitely worth getting into. There are a lot of folks in VC who are super into it. Check it out. And we have things like Axe Core, JSX Ally, the Lighthouse API for accessibility. So these are ones like you can just run as your code, like run as part of your code testing, and they are super powerful as well. And I think that's all that I got.